Hello. Before we dive into solving physics problems, there's one tool you absolutely need in your toolbox: trigonometry. Whether it's breaking down forces on an incline, analyzing periodic motion, or just working with wave, trig shows up everywhere in physics. This lesson will focus on the essentials: right triangles and the unit circle. First, we'll see how sine, cosine, and tangent lets us move between angles and side lengths in right triangles. Then we expand those same ideas to the unit circle, where trig really comes alive and connects directly to motion and periodic behavior in physics. Let's get started by reviewing the building blocks: right triangles. Okay, most of you have learned SOH-CAH-TOA, where sine is equal to opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, and tan is equal to opposite over adjacent. So I'll let this be the base. This is my height or altitude, and this is the hypotenuse. So the Pythagorean theorem says that a squared plus b squared equals c squared. These are the main formulas that we'll be using throughout this lesson. So let's find sine, cosine, and tangent of theta in this diagram. Okay, so I see that the tan here is opposite the angle. The 24 is adjacent to the angle. And this is the hypotenuse here. All right, so the first order of business, if we need to solve for the length of hypotenuse, we'll say a squared plus b squared equals c squared. If this is b, this is a, and this is c, then I can say 10 squared plus 24 squared equals c squared. So 100 plus 576 equals c squared. So c squared is equal to 676. So c then would equal the square root of 676. So c will equal 26. So I know that the length of this side here is 26. So the sine of theta is going to equal opposite over hypotenuse. So the opposite side is 10, the hypotenuse is 26. This will reduce down to 5 over 13. Cosine of theta, which is equal to adjacent over hypotenuse. So the adjacent side is 24, the hypotenuse is 26. This reduced down to 12 over 13. And tan theta is equal to opposite over adjacent. So that will be 10 over 24, which reduces down to 5 over 12. Find sine, cosine, and tangent of theta in the following diagram. The hypotenuse is 8. The base of the triangle is 4. Okay, so first of all, we need to find a. Okay, so a squared plus b squared equals c squared. So a squared plus 4 squared equals 8 squared. A squared plus 16 equals 64. 8 squared, rather, will equal 48. So A would be the square root of 48. Note now that square root of 48 isn't in standard form. Okay, so I need to look and see if I can correct this. I know that 48 is equal to 16 times 3. So A will equal 4 square root of 3. So now I know all three sides. So now we can solve for sine, cosine, and tangent. Okay, so sine is equal to the side opposite over hypotenuse. So side opposite is 4 over 8, which reduces down to 1/2. So cosine theta is equal to adjacent over hypotenuse. So the adjacent side is 4 square root of 3 over 8. I can divide by 4 there, so it gives me the square root of 3 over 2. Tan theta is opposite over adjacent. So tan theta is equal to 4 over 4 square root of 3. This would give me 1 over the square root of 3. This is not in proper format here, so let's tweak it a little bit. So I'm not allowed to have a radical in the denominator. So let's rationalize it by multiplying both the top and the bottom by the square root of 3. So this will give me the square root of 3 over 3. Okay, that would be our final answer for tan theta. The most common angles used are 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. In the next couple slides, we will work triangles using these angles. All right, so the first one here is an isosceles triangle, or a 45-45. On a 45-45, if we let the base and A equal 1, then the hypotenuse then is 1 squared plus 1 squared so C is equal to the square root of 2. So I just choose whichever angle I like. So sine will be equal to opposite over hypotenuse. So that will be 1 over the square root of 2. And since we can't have the radical in the denominator, we're going to multiply the top and bottom by square root of 2. So that's going to give me the square root of 2 over 2. So the cosine of theta will be the same thing. So it will be 1 over the square root of 2, which is equal to the square root of 2 over 2. Tan theta will be opposite and adjacent. So opposite over adjacent, so that will give me a 1. So that's the sine, cosine, and tan thetas for a 45-45 degree triangle. Let's look at a 30, 60, 90. Okay, so if I'm using sine of 30, that's going to be the opposite over the hypotenuse. Okay, so the opposite is 1, hypotenuse is 2. The cosine of 30 is the adjacent and hypotenuse. So the adjacent would be the square root of 3 over 2. And the tan of 30 will be the opposite over adjacent. That's going to equal 1 over the square root of 3, which then becomes the square root of 3 over 3 after I rationalize. To solve for the 60, so the sine of 60 degrees, that'd be opposite, so that'd be square root of 3 over 2. That's my final answer. Cosine of 60, adjacent and hypotenuse, so that'd be 1 over 2, final answer. And then the tan of 60, that'd be opposite and adjacent. That's the square root of 3 over 1, which is the square root of 3. So that gives us our 45-45 and our 30-60 triangles. The trick to evaluating the trig functions at 0 is to visualize a small angle theta and apply the limit that theta approaches 0. So as theta approaches 0, this side gets shorter and shorter. The side adjacent will be approaching 1. So if the side adjacent approaches 1, then I can say then the sine of 0 degrees will be opposite over hypotenuse. So opposite will become 0. The hypotenuse is 1. That tells me then the sine is 0 then, for 0 degrees. For cosine of 0 degrees, okay, we said that the adjacent side will be approaching 1. So it'd be 1 over 1. So cosine of 0 degrees equals 1. The tan of 0 degrees okay, opposite side will be 0, adjacent side will be 1. So that will give me a 0 also. For 90 degrees, visualize the large angle here. Apply the limit that theta approaches 90. As the angle approaches 90, the opposite side approaches 1. So this will be getting closer and closer to 1. This will be getting closer and closer to 0. So I can say then that the sine of 90 degrees is equals opposite over hypotenuse. So that's 1 over 1. So we can say it's 1. The cosine of 90 degrees is adjacent over hypotenuse. So adjacent is approaching 0. Hypotenuse is 1. So that would give me a 0 for my answer. So tan of 90 is opposite over adjacent. So that's going to give me 1 over 0. And that's undefined. So all those trig values are summarized in the following table. Okay, so sine of theta for 0 is 0. For 30, it's 1/2. Square root of 2 over 2. Square root of 3 over 2. And 1. For cosine, you have 1. Square root of 3 over 2. Square root of 2 over 2. 1 over 2 and 0. Okay, so square root of 3 over 3. 1 square root 3 and undefined. We'll be using these numbers constantly in physics. So it wouldn't hurt to be able to either memorize these or to be able to solve them like I shown you earlier. This is the unit circle. Oftentimes math teachers present this and tell the students that they have to memorize it, and that generally just terrorizes the students. Let me show you an easy way to remember this or to be able to draw this without having to memorize the entire thing. Remember that the circumference of a circle is equal to 2 pi times the radius. Well, if we let the radius equal 1, okay, then circumference then is equal to 2 pi. So we're going to start from this point here and move along the circle counterclockwise until we form whatever angle that we desire. So let me go ahead and draw some lines here. So this will be 0, 1, so on and so forth. All right, so as I start finding a point along this circle here, the y value is always going to be the sine of theta, and the x value is always going to be the cosine of theta. So that's something to remember. Okay, so let's erase most of this. Let's go back to a circle. So if this is 0, this is 90, 180, and 270 degrees. We're going to break this up into blocks of 30 degrees, 45 degrees, and 60 degrees. No, the circumference is 2 times pi. So this is going to be pi here as I'm moving around. At 90 degrees, it's going to be pi halves. At 270 degrees, it's going to be 1.5 pi, so that's going to be 3 halves pi. So when I get back here, this will be 2 pi. Okay, so a complete circle is 360 degrees. So if I say 360 degrees divided by 30 degrees, that will give me 12 divisions. So I have 6 divisions on the top, 6 divisions on the bottom. Let's identify all these positions 30 degrees at a time. So at 0 degrees, I have 0 pi. At 30 degrees, I will be 1/6 of the way around to 180 degrees. So that'll be pi 6. At 60 degrees, I'll be 2/6 pi around, which is pi thirds. At 90 degrees, I'm 3/6 pi, which is pi halves, which corresponds to what I have written already. At 120 degrees, that'd be 4/6 pi, which is equal to 2/3 pi. At 150 degrees, that's equal to 5/6 pi. At 180 degrees, that's equal to 6/6 pi, which is 1 pi. Okay, the same thing going on the bottom half. So I have 210 degrees, which is 7/6 pi. 240 degrees is 8/6 pi, which reduces down to 4/3 pi. 270 degrees is equal to 9/6 pi, which is 3/2 pi. 300 degrees is 10/6 pi, which reduces down to 5/3 pi. 330 degrees equals 11/6 pi. And 360 degrees is 12/6 pi, which is 2 pi. Now let's do the divisions for 45 degrees. Okay, so for 45 degrees, there's 8 divisions. So 4 on top, 4 on the bottom. So for 45 degrees, it's 1/4 of a pi. 135 degrees is 3/4 of a pi. We did 180 earlier. 180 is 4/4 of a pi, or 1 pi. The next one is 225 degrees, which is 5/4 of a pi. We already did 270 degrees. That's 6/4 of a pi, which is 3/2. And the last one will be 315, which is 7/4 of a pi. 360 is 8/4, which is 2 pi. Okay, on this screen, I'm showing you all the previous calculations all in one screen. Notice that the blue represents all the 45-degree angles, while the red represents all the 30-degree angles. So the blue will use the denominator of 4, and the red uses the denominator of 6. Now let's tackle the coordinates for each of these angles. We'll do an XY coordinate for each one. The first one will be the cosine of theta sine theta. So this is your X and this is your Y. Now we can go through and use the values that we learned earlier. However, there's a trick so you don't have to memorize quite as much. The trick is, if I were to put a 1, a 2, a 3 here, divide each one by 2, then take the square root of the numerators. For the other ones, let's just go in reverse order. 3, 2, and 1. Divide each one by 2. And then take the square root of the numerator in each. Okay, so that gives me the coordinates for those angles. We automatically know this one is 1, 0, and this one is 0, 1. This one will be negative 1, 0, and the bottom one here is 0, negative 1. All right, so here's the trick. This is 30 degrees above my reference line, x equals 0. This one is 30 degrees below it, so it'll be the same value. The only thing I have to change is the sign, because I'm now in quadrant 4. So in quadrant 4, I know that my x is positive. I know that my y is negative. So I'll put a negative here. This is 30 degrees above the reference line. I will go with square root of 3 over 2 and 1/2. In quadrant 2, I know that this will be negative, the other will be positive. This angle is 30 degrees below the reference line, so it would be the square root of 3 over 2 and 1/2. In quadrant 3, I know that this is negative as well as this one is negative also. Okay, let's try the 45s here, okay? So I will take this line, follow it down. So this 45 will have the same coordinates as this 45 here, so it's going to be square root of 2 over 2, square root of 2 over 2. Let's get our signs right. This would be negative, and this would be negative. Let's take the other 45s. Again, they're going to be square roots of 2 also. So this is going to be square root of 2 over 2 and square root of 2 over 2. Work on our signs. X is negative, y is positive. And the other one down here is going to be square root of 2 over 2 and square root of 2 over 2. Let's get our signs right. X is positive, y is negative. So all we lack is just one more grouping. Okay, 60 degrees. This one is 60 degrees. It's going to be the same thing. Let's try to squeeze it in here. So I have 1/2 and the square root of 3 over 2. All right, let's work on our signs. X is negative, y is positive. Good. Okay, so this is 60 degrees from the reference. We'll use the same numbers again. So this is going to be 1/2 and the square root of 3 over 2. Let's get our signs right. They'll both be negative because of this quadrant. And the last 60 is here. So again, it's going to be 1/2 and the square root of 3 over 2. And our signs, x is positive, y is negative. So basically, we have done the entire unit circle. You now know the angles, and you know the coordinates for each one. In case you didn't catch all the signs that I was using earlier, in quadrant 1 here, all functions are positive. In quadrant 2 here, these are positive. In quadrant 3, these are the positive ones. And in quadrant 4, these are the positives. So that's the foundation, using sine, cosine, and tangent with right triangles and extending those relationships to the unit circle. These skills will come in very handy again and again in physics. Whether you're breaking vectors into components, analyzing motion, working with waves, if you get these trig tools down, you're ready to tackle the problems ahead. Thank you for watching. Please like and subscribe, and I'll see you again soon. Thank you. Goodbye.